Let us solve some examples of double integration. But before that, let us understand how the limits of integration be there in some kind of region. Like if you have a region, so let a region R be bounded by the curves, say y equal to y1 is a function of x, y equal to y2 function of x, and the lines x equal to a and x equal to b. So we have like this. Say we have, say suppose say here line x equal to a, line x equal to b. This is say y equal to y1 function of x, y equal to y2 function of x. And this is the region R of integration. So basically what we are doing here is we take a vertical strip inside the region, and then we see that ends of this strip is from y equal to y1x to y2x. And that strip slides from here, x equal to a, to x equal to b. That strip sometime here, sometime here, sometime here. So we have the integration like this. The double integration over R fxy is like y equal to y1, a function of x, to y equal to y2, a function of x equal to a to b, fxy, dy, and then dx. It may also have like region R bounded by the curves, say x equal to x1, a function of y, x equal to x2, a function of y, and the lines y equal to c, y equal to d. So we have like this. Say suppose we have the uh, region like say line. This is say y equal to d line. This is say y equal to c line. This is curve say x equal to x2 of y. This is x equal to x1 of y. So here we take the horizontal strip inside the region, and then we find the limits of integration, and then we solve. So the integration can be solved like this: x equal to x1y to x equal to x2y, y equal to c to y equal to d, fxy dx dy. This strip slides from here to here. So y is from c to d, horizontally strip, horizontal strip, and it slides vertically. While here the strip is vertical, it slides horizontally. Both ends on the curve, and here also the both ends here. One end is on x1y, another end is on x2y. So we can solve some examples. So evaluate integration from 0 to x, from 0 to 1, e to the power y by x dy dx. So here y is the function of x. So this limit is for y and another this limit is for x. So first we need to integrate with respect to y. So integration of e power y by x with respect to y is e power y by x, and divided by the derivative of y by x with respect to y is 1 by x, and limit y equal to 0 to x. So this is equal to 0 to 1. This is x. Now y is x. So this is e power x by x, and so that is 1. Y is 0. So e power 0, and that is 1. So this is e power 1. That means e power 0 is 1. So this is e minus 1. Integration of x is x square by 2, and x is 0 to 1. So this is 1 by 2 into e minus 1. Let us take one more example. Evaluate integration 0 to 1 x to x square xy dy dx. So this limit is y is a function of x. So y equal to x square. This is x equal to 0 to 1 xy dy dx. So integration first with respect to y. So x is 0 to 1. Integration with respect to y. So that is y square by 2. Y equal to x, 2y equal to x square dx. Limits. So this is 1 by 2. Y square. Y is x square. So this is x square square minus y is x. So x square dx. And so this is 1 by 2. X is 0 to 1. This is x power 4 multiply x. So that is x power 5. X square multiply x. So that is x cube dx. And so this is x power 6 by 6 minus x power 4 by 4, 0 to 1. And so this is 1 by 2, 1 by 6 minus 1 by 4. And simplify this. So this is a minus 1 by 12. So that is minus 1 by 24. Next, evaluate integration 0 to 1, integration 0 to root 1 plus x square dx dy over 1 plus x square plus y square. Now, this is a function of y. So y equal to 0 to root 1 plus x square, and x equal to 0 to 1. This is a dy upon 1 plus x square plus y square and dx. This is x equal to 0 to 1, y equal to 0 to root 1 plus x square. This is dy upon, now integration with respect to y. So this we can write as root 1 plus x square and its square. This is constant when we integrate with respect to y plus y square and dx. So we have integration 1 upon x square plus x square kind of integration. And that we know as 1 upon a tan inverse x by a. So x equal to 0 to 1. This is a is root 1 plus x square. So 1 upon root 1 plus x square, 1 upon a. Tan inverse x, x is root 1 plus x square by y, by tan inverse x by a. So, sorry, this is a tan inverse x by a. So, variable is y and a is root 1 plus x square. And this is equal to y is from 0 to root 1 plus x square. So now this is x equal to 0 to 1, 1 upon root 1 plus x square. This is tan inverse now root 1 plus x square upon root 1 plus x square. So that is 1. And tan inverse y is 0, then it will be 0. So tan inverse 1 is pi by 4. Tan inverse 0 is 0. X is 0 to 1. And this is 1 upon root 1 plus x square dx. Now this is standard integration 1 upon root a square plus x square. So this is equal to pi by 4 log of x plus root a square plus a square, that is root 1 plus x square, and x is 0 to 1. So this is equal to pi by 4 when we keep 1 here, keep 1 here. So this is log of 1 and root 2 here. So this is 1 plus root 2. And when we keep 0, x is 0, then this is log 1. Log 1 is 0. So this is pi by 4 log of 1 plus root. Next example, evaluate integration 0 to root 1 minus y square by 2, 0 to 1 dx dy upon root 1 minus x square minus y square. Now this limit is for variable x. X is a function of y. So x is equal to 0 to root 1 minus y square by 2. Y is 0 to 1 dx 1 upon root 1 minus y square minus x square. And now this is also like integration root a square minus x square. So that is nothing but sine inverse x by a. So this is equal to y equal to 0 to 1. Now sine inverse x, what is a here? So a square is 1 minus y square. So a is root 1 minus y square. And x is equal to 0 to root 1 minus y square by 2 dy. So y equal to 0 to 1. This is sine inverse. Now root 1 minus x y square by 2 and root 1 minus y square. So root 1 minus y square cancel. Remaining is root 1 upon root 2. This 1 upon root 2 will be. And minus sine inverse 0 is 0. And sine inverse 1 by root 2 is pi by 4. Y equal to 0 to 1 dy. So this is pi by 4 into 1. So that is the pi by 4. So these are the kind of examples where we have the limits of integration given in terms of variable. We shall solve some more example in the next video. Thank you.